So let's move to question number 8 from the chapter Work, Energy and Power. It states that the upper half of an inclined plane, inclined at an angle theta with the horizontal, is perfectly smooth and lower half is rough. A block starting from rest at top of the plane will come to rest at bottom if the coefficient of friction between block and lower half of plane is. So we'll proceed with the solution part.
Yeah. First let us analyze the question. It is given the inclined plane. Let us assume the angle of inclination is theta and is equal to height h.
Okay.
So it is given the first half of the inclined plane mu is equal to 0 and the second half mu is equal to we need to actually find that. Let us assume this mu is equal to mu. In the given question, firstly the body is left initially from point P and the final position of the body is point Q. At point P the initial velocity of the body is 0 and also the velocity of body at point Q is also 0 because the body is starting from rest and it comes to rest at the bottom when it traverses the path of friction mu. So now let us first find the position. Let us name this as S. We'll find the height of this. We'll find the height of S from the ground as given theta. This will be.
Okay, you are finding both the vertical as well as the horizontal coordinates of.
No, actually we are just finding the vertical height coordinates.
Okay.
We know this is L by 2 and this is L by 2. As we are just imagining this length of the inclined plane is L.
Right.
So from the triangle QP, let us consider this as O and this is R. In triangle QPO and QSR, as both are similar triangles, we will be getting L by 2 by SR is equal to L by H. So in this way you will be getting SR is equal to H by 2. So the position S will be at height H by 2. So let us now consider the energies at positions B, P, Q and S, because while doing this problem we actually take the work done by the conservative forces and the non-conservative forces.
One thing I would like to ask, why didn't you write SR in terms of theta and L by 2?
Actually when we are just considering the potential energy we need to have the height, so I considered SR in terms of H by 2.
Fine.
Let us take at position P. It is having initially the potential energy is equal to mgh and kinetic energy is equal to 0.
Right.
And now let us take at position S. Let us assume this velocity be Vs. Potential energy at position S is equal to mgh by 2.
Correct.
Because it is at height h by 2, and kinetic energy at position S is equal to half m Vs square. According to law of conservation of energy, energies at positions P and energies at position S should be equal. So that is mgh is equal to mgh by 2 plus half mvs square. In this way we will be getting half mvs square is equal to mgh by 2.
So this we assume because the work done in this case by the frictional force is 0, since mu is equal to 0.
Yes, in this position work done by the frictional force is equal to 0. So just by the conservation of energy we found velocity Vs at position S. Now go to the position S. Now the body traverses from position S to Q. In this case the work done by the conservative or non-conservative forces is not equal to 0. We have a non-conservative force, that is friction.
Okay.
Work done by the non-conservative force, that is equal to friction, is equal to change in the, according to work energy theorem, is equal to negative of change in mechanical energy.
Right.
So let us assume the free body diagram of the body at position S. In this position S, we are having the frictional forces in the opposite direction of movement of the body.
Right.
So frictional force will be in this direction and the normal reaction will be a perpendicular to the inclined plane. We
Correct.
know gravitational force is in this direction. As we know, this is theta. This component will be is equal to mg cos theta. In these coordinates, there is no other external forces acting on the body, so n will be equal to mg cos theta. As we know, frictional force is equal to mu into normal reaction acting on the body. This will be equal to mu mg cos theta. So work done by the non-conservative, now we consider the work done by the non-conservative force, that is equal to frictional force, that is equal to force into x. X is the distance traversed by the body. We
Right.
know F is equal to mu mg cos theta and x is equal to L by 2.
Will there be a minus sign in this work?
No, actually the work done by the frictional force in this case is directly, we are just equating because it is an inclined plane.
Okay, so
need
we
not
are
consider
assuming this
different-
work is done by the force.
Yes.
Okay.
Work done by the force. So in this way we will be getting work done by the we are just equating the work done by the non-conservative force is equal to change in the mechanical energy.
Correct.
The final mechanical energy we know that is 0. Let us take change in mechanical energy. Final mechanical energy is 0 because at position q it is at height 0 and also the final velocity is 0, and this is equal to 0 minus of we are having the energies at position S. Let us say this is as ES.
Okay.
So this is equal to work done by the non-conservative force is equal to negative of delta ME. So this will be equal to ES, work done by the non-conservative force.
Correct.
We know we got here work done by the non-conservative force is equal to mu mg cos theta into L by 2, and at ES we have got the equations here. We have got the equations here, that is potential energy plus kinetic energy. Kinetic energy is half mvs square plus potential energy at vs will be is equal to half
mgh by
mgh
2.
by 2.
Correct.
And from the above equation we actually got half mvs square is equal to mgh by 2. So mgh plus mgh by 2 plus mgh by 2 will be equal to mgh. From this equation, by solving this, we will be getting, just by solving this equation we will be getting mu mg cos theta L by 2 is equal to mgh.
Right.
This will be equal to mu cos theta by 2 is equal to h by L. Actually from the above inclined plane diagram we will be getting h by L is equal to sin theta. This is a general formula in trigonometry.
Yeah.
This will be equal to sin theta. So here tan theta will be equal to mu by 2. As in the given equation we have theta, so the mu will be equal to 2 tan theta.
Okay, so as we have seen in this question basically tests the concepts related to the work energy theorem and the conservation of mechanical energy. So students need to be very careful in considering the work done by a non-conservative force, since the half of the plane we saw the work done by the frictional force is 0, but in when we are considering the other half, since there is some coefficient of friction associated with it, we need to take that work into account. Fine, let's move to question number 9. In this question, a figure is shown, a smooth pipe which is bent in the form of a circle and kept on floor, keeping its axis horizontal. Two identical particles are released from the top and they start sliding down. It has two parts. The first part states that we need to find at what angular displacement of each particle does the normal reaction between the pipe and floor becomes minimum, and then we need to find the least possible ratio of the mass of each particle to the mass of the tube, so that pipe loses contact with floor at some point of time during the motion of the particle. So we'll move towards the solution part.
Yeah, basically in this question, let us just take this as the ground and radius as r. There are two identical balls here mentioned. So let us take the normal reaction of total system from the ground is n dash,
Okay.
and the normal reaction of the small two identical balls on the pipe is n. As for both balls the normal reaction will be is equal to n. Let us just consider for one ball. So now initially taking the free body diagram of entire system, n
Okay.
dash will be in the upward direction, and the normal reactions of the two balls on the system is in this way, and we know as this angle is theta, this will be equal to n cos theta. So and also taking the entire mass of the system is equal to m. The energy force equation we get is equal to n dash minus 2n cos theta. Why we have written 2n cos theta is for individual ball, for individual identical ball it's n cos theta downward, so for two balls it will be minus 2n cos theta.
So why would this angle theta be the same? Will the two balls be traversing the same angle theta in a certain amount of time?
Yes, it will be traversing the same amount of distance, same amount of angle theta.
Okay, that
at
is
any
because the
particular-
balls are identical. It's given.
balls are identical and that are released at the from the same point.
Okay.
So mg will be acting in the downward direction. Capital, this is note, this is capital M, downward direction, this is minus mg is equal to ma. As the pipe is given, it is fixed, it's not moving, a will be equal to 0, so we get n dash is equal to plus 2n cos theta plus mg.
So this is the
This is
equation,
capital M.
fourth equation for the entire system.
Yeah, entire system.
Okay.
Let us name this is equation as 1. So now just take the force equation of identical balls. Normal reaction will be acting vertically in a perpendicular distance to the instantaneous velocity,
Right.
and gravitational force will be acting downwards, and we know this angle is theta, so this will be equal to mg cos theta. And as it is moving in a circular path, we will be having a centripetal force, and let at the instance, let us take this as p point, this point as p point. At that instant, let the velocity be equal to v, so the centripetal force will be equal to mv square by r. So by this way we will be getting, just by writing the force equation, we get mv square by r is equal to mg cos theta minus n. Note here, this is the mass of a particular ball, so this is small m and this is capital M. Let us name this equation as 2. From the work energy theorem, from the conservation of energy, we can even write like this: change in potential energy is equal to change in kinetic energy. At the initial position, the velocity is equal to 0.
Right.
So the velocities will be equal to 0. We will be taking for a particular ball. So initial energy is equal to 0, and we assume the final velocity is half. Final velocity as v. The kinetic energy will be equal to half mv square minus 0, and the potential energy will be equal to, initially it is at a height, let us just assume this as the 0 potential energy level.
Okay.
Initially the ball is at height r, and then it has moved, traversed an angle of theta, so this angle will be is equal to r cos theta. So it has come down by a distance r into 1 minus cos theta, so this will be equal to change in potential energy.
Okay.
So here we can just write mv square by r is equal to 2 small m g into 1 minus cos theta. Let us name this equation as 3.
Right.
So from equations 1 and 3, from the equations 1, from the equations 2 and 3, just we will be getting 2
So you
into mg 1 minus cos theta will be equal to, as this is mv square by r.
So
and
you will
this is-
substitute its value
yeah,
in this
just we are
equation.
substituting. This will be equal to mg cos theta minus n. Here just by solving the equation we will be getting n is equal to 3 mg cos theta minus 2 mg. Putting this in equation number 1, we will be getting n dash is equal to 2n cos theta plus capital mg. Just by solving the equation we will be getting minus 2 into 3 mg cos theta minus 2 mg into cos theta is equal to capital mg plus n. As we required n dash, as we required in the given question, what it is asked is, at what angular displacement of each particle does the normal reaction between the pipe and floor will be minimum. So for the minimum normal reaction, what we assume is just take the differentiation of dn dash is equal to 0. Thus,
Okay, you're differentiating with respect to theta.
yes, we are just differentiating with respect to 0. With respect to theta, why we are differentiating is, when we need to find a minimum of any quantity, just we differentiate it and then we check whether it is the minimum or not.
Okay.
So just by the differentiating we will be getting 12 sin theta cos theta minus 4 mg sin theta. Yeah, here I missed this term. 12 mg sin theta cos theta minus 4 mg sin theta is equal to 0. Just by solving this equation we will be getting cos theta is equal to 1 by 3. That implies theta is equal to cos inverse of 1 by 3. So at an angular displacement of cos inverse of 1 by 3, the normal reaction will be equal to minimum.
So that solves the first part of the question.
Yeah,
So,
let us move to the second part of the question. In the second part of the question, he asked when it loses the contact. When the body loses the contact of the floor is when n dash is equal to 0.
okay.
So in this case, from the, let us take this equation as 4. From the equation 4, just we put the n dash is equal to 0. We will be getting minus 2 into mg minus 2 mg into cos theta. So here cos theta is 1 by 3. Just we are substituting this as 1 by 3 is equal to capital mg. So from this we are getting small m by capital M is equal to 3 by 2. So this is the ratio of identical balls, ratio of each identical ball to the pipe. If it is in this case, the body loses the contact of the ground.
Okay, so basically the concepts which we have studied in this, again, the free body diagram concepts which you have already studied in the chapter on laws of motion. So you need to basically draw the free body diagram of the entire system as a whole and then consider the effect of various forces which are acting on the entire system. And in the second part, we also considered the case where the body loses contact. We need to assume the normal reaction at that instant of time becomes 0 and then solve the equations and get to the final answer.